Oh, good morning, everybody. We are live, so we're gonna do this. 1 month to go. We can go. We can do it. Don't forget, you guys need to finish up Chapter 7 if you're not done. Most of you are done, but if you need a copy of the test from Chapter 7, please ask me. I've got great notes on it. G Test 7 if you want to watch it. G for Geometry, Test 7. I don't do the test for you, but I do an awful lot of it, so it's really a nice little guide for taking the test. Most everybody seems to be getting a B's and A's on it, so just take the test, okay? Now, homework. Let's take a look at last night's homework first of all, and then we'll move into the lesson. So, here's what I have for my homework. You can see that I moved it from here to here, and then I made it bigger, and here it is. Here's the coordinates. I took it from here, then I flipped it to here. No, that's not true. I went from here, made it smaller to here, then I flipped it, okay? And there's my new coordinates. 3, I took it from here down to here, and then I made it, oh, that's not true. From here, 90 degrees to here, and then I reduced it. Okay, there we go. 4, what I did is I made it half as big, and then I moved it over 4 and down 1. On 5, I flipped it over the y, that's why the negative xy, and then I made it twice as big. Here what happened is I had to make it 1/3 as big, which brought it down here, and then I flipped it over the y. No, I went 90. I went 90 degrees this way. I did. That's why it's a negative y. So I went what used to sit right here, and then I went 90 degrees that way. Okay, so that's the homework from yesterday. So please send that to me if you haven't. So today's lesson, let's take a look at it. So similar polygons. What we know about similar polygons is to have the same shape, but different size. Similar polygons. You know, like triangles, quadrilaterals, pentagons. So what we know about them is this: if they have the same shape, then their corresponding angles will be equal, okay? So that means corresponding angles are congruent. Congruent's a word meaning the same. Congruent. Okay, this word congruent means basically equal, but we don't say angles are equal. We call it congruent. Now, if the angles are equal, right? For instance, if I take a look at this figure right here, angle I is congruent to angle Z. We can just say angle I is congruent to angle Z. That makes sense. I don't know what the measures are, but they sure look like equal angles. Angle R is congruent to angle X. Okay, that makes sense. It looks like it. So I'm going to mark it because I like to mark my figures. So angle I is congruent to angle Z. Angle R is congruent to angle X. And angle S is congruent to angle Y. Okay, let me mark that figure, okay? Now I like to also say this. I can say then that triangle IRS, and this is the symbol, watch this, is similar. That's my symbol to triangle. Now you got to do it in the right order. IRS, you got to go the correct order. Z, X, Y. You got to go the right order. I goes to Z, so I'm going to go IRS to ZXY. So this is the symbol for similar. Now they're not equal, they're not congruent, but they are similar. So that's my similar symbol, because the triangles have the same shape but different size. So same shape, different size. What do we know about the sides? So the sides are what we call proportional, okay? Sides are proportional. Okay, which means they have the same ratio, okay? ratio, same ratio. Okay, so ratio, the word ratio is a fraction. Always has been. The word, you see the word ratio, it's a fraction. So here's what we're going to do. We're going to say this. We're going to say that IR, see how IR goes to ZR this side, I'll mark it. Where'd my pens go? You know. Alright, we'll just mark it this way. So I can see that this side corresponds to this side. You can see it. That side goes to that side. So I could say that IR corresponds to ZX. See, I wrote it as a fraction because of ratio, okay? And we could say RS corresponds to XY, which IS corresponds to ZY. Now let's check it out. If that's true, I've got some numbers here. Their ratios should all be the same. So if the ratios are all the same, let's check it out. So my ratios are, let's see, 25 to 15 should be equal to 20 to 12, which should be equal to 30 to 18. So let's see, if I reduce this by 5, I get 5 thirds. If I reduce this, see, by 4 and 4, I get 5 thirds. If I reduce this by 6, I get 5 thirds. So here's what we know, that the ratio is 5 thirds. The ratio from this one to this one is 5 thirds, okay? Now, I've got this, I already did this, I'll do it again. Well, I don't need to do it again. This is triangle IRS. Triangle IRS is similar to triangle ZXY. And you have to put the angles in the correct order, okay? Alright, what's the ratio of similarity? We found it. There it is, 5. What is the ratio of similarity? It is 5 thirds. Awesome. Okay. Example 2. So in example 2, let's find some things, okay? So if they are similar, this figure, this quadrilateral, is similar to this quadrilateral. What we need to do is find the missing side. So the value of x here corresponds to 4, okay? But before we do anything, let's figure out, let's back up to this one, sorry. Let's do this example first, and then we'll do this one, okay? So let's take a look. So first of all, what we have to do is figure out what the ratio is. I'm going to figure out what the ratio is. And the thing about the ratio is I can use either these two sides or these two sides. It does not matter. I'm going to go 15 to 18. So I'm going to say 15 to 18. Watch this. 15 goes to 18. This side goes to this side. Remember, we're looking for a ratio, which is a fraction. So I'm going to go 15 to 18 is equal to x to 30. So I did that. This side goes to this side as this side goes to this side. So now all I'm going to do is just cross multiply and solve. So if I bring up the 30, I'm going to multiply up the 30 times both sides by 30 times by 30 to solve, right? Then I'll have 15 times 30, which I think is 450. Let's calculators here. 30 times 15 is 450 divided by 18. And I get an answer of 25. So I know this side is 25. Awesome. Okay, let's look at this other example. Same type of thing, okay? If I know the two figures are similar, it says they are similar, so this quadrilateral is similar to this quadrilateral, then what I need to do first is find the ratio of similarity. So it looks like it's twice. See, I can go 10 to 5, that's pretty easy. 10 to 5, which is twice as big, so obviously that's going to be 8, but let's set it up. 10 goes to 5 as x goes to 8. Oh, 4. I've got the answer in my head. So if I multiply by the 4, multiply by 4, multiply by 4, 4's will cancel. 40 divided by 5 is 8. But I knew that already because remember you can say 10 to 5, 12 to 6, 16 to 8's got to be, that's got to be 8. I mean, I can just see that. I don't need the math. Okay, so far so good. Let's turn the page. Here we go. Okay, now find the perimeter. This gazebo. Oh, you can just imagine that's gazebo. This gazebo. Okay, so let's find the perimeter of gazebo B. So what I have to do is this. I don't know all the rest of these pieces, but I don't need to because I just need the perimeter. So what I can do is this. I can find the perimeter of B. Okay, what's the perimeter of B? Well, let's just add them all up. Just use my calculator. Okay, ready? Just go 15 plus 9 plus 12 plus 15 plus 18, okay? Gives me an answer of 69. So the perimeter is 69, okay? Now I need the ratio because the perimeters should have the same ratios, okay? So let me find the ratio. So the ratio, I can pick any two. So let's go 10 to 15 because those go together. So the ratio is 15 to 10 or 10 to 15. I think I'll go this way because I kind of know what I'm doing. Let's go 15 to 10 because I want to find A. Oh no, I'll go the other way. 10 to 15 is my ratio. Is got to be perimeter to perimeter. Okay, so then perimeter of this one to the perimeter of this one. Show it again. So 10 goes to 15 as the perimeter of this one goes to the perimeter of this one. Okay, so let's multiply by 69. Solve. Multiply by 69. Multiply by 69. And okay, just use my calculator. I'm going to go 69 times 10 divided by 15. Get an answer of 46. Okay, so perimeter of this one, even though I don't know all the other sides, has to be 46 because it has the same ratio. Okay. Now area. Before I do area, I'm going to take a look at something else first. Okay. Now area is different. Area is different because it's two-dimensional. So first of all, take a look at this. So the perimeter. Let's check out the perimeter. I know 3 plus 4 plus 3 plus 4. Sorry. So there's 7, 7, right? 14. So the perimeter is 14. Now the area of this one is base times height, which is 12. Now let's triple it. So let's make this thing bigger. Okay, just use your imagination. Just tripled it. So that means this one's going to be 9 and 12. Okay. So the perimeter now, let's see, this is also a 12, that's a 9, okay, 12, 9, clear. So I've got 24 plus 18, so the perimeter is 42, which is 3 times as big as this. But watch the area. Area is different. 9 times 12 is 108. So the area is 108. Now that's different. That is not 3 times as big. So what happens is, because it's two-dimensional, 2D, right? Two-dimensional, you're going to multiply the length and the width by 3. So you're going to take your ratio, and you're going to take your ratio, and you're going to, for area, you're going to take your ratio and square it, because you're going to go to two-dimensional, okay? So you are going to triple it and triple it, which is 3 times 3. So this one's actually 9 times as big. You can check it. What's 108 divided by 12? It's 9 times as big. So if we know that, we go into area, we're going to take r squared for our scale. All right, r squared for our scale. Okay, so let's see how that works. Okay. So in this diagram, triangle ABC is similar to triangle DEF. Okay, got that. Now what I know is this. For the area, I know the ratio is going to be 10 to 5 or half as big. Okay, it's 10 to 5. So R equals 10 to 5, or R equals 2. Okay, now the area is different. So now if we want to go to area, we're going to take the ratio and square it, which is 4, okay? So it's 4 times as big. The perimeter is only going to be twice as big, but the area is going to be 4 times as big. So let's set it up. We're going to go our ratio of, okay, our ratio squared. So we're going to go and take, first of all, our area of this one to area of this one. So we're going to go 36 to area equals our ratio. And our ratio is going to be 4 to 1, okay, because it's ratio squared. So really, if I cross multiply, I'm going to go that times that. I'm going to go 36 is equal to 4 times my area. And then I'm going to divide by 4, and I get 9. So it's really going to be 4 times as small. Okay, so the area of this one is going to be 9 centimeters squared. Okay, all right, that's a little tricky. If we had a test this year, that's a pretty typical question on the test. It's area 2. Okay, so homework today, you guys. Homework is going to be found on page 263, 1 through 8. All, please start sending stuff in to me. Okay, let's take a look at it. 262. Real quickly, 262. 263, sorry, 1 through 8. Are they similar? Find the value of x. Find the scale factor, find the values x, y, and z. Find the perimeter. And then the area, okay? And the area is the only tricky one here, okay? And that's all I have. Talk to you tomorrow.